Light energy part 2. Refraction of light. Place a pencil in a glass of water and immerse a coin in a glass of water. What do you notice? The pencil appears to be bent at the point it enters the water and the coin appears to be raised. This optical effect occurs due to the bending of light. One light travels from one transparent medium to another transparent medium of a different density. It bends from its original path at the surface of separation of the two media. This phenomenon of bending of light is called refraction. How refraction occurs. Refraction occurs because light travels through different media at different speeds. The media in which light travels faster are called optically different rarer media, and those in which light travels slower are called optically denser media. When light enters an optically denser medium, its speed becomes slower. To compensate for the change in speed, light readjusts its path to choose a shorter route out of the denser medium. The reverse occurs for light entering an optically rare medium. Thus refraction occurs. Effects of refraction of light. Let us again consider the case of the pencil immersed in water. The ray of light from the tip of the pencil, A, travels from an optically denser medium, water, to an optically rare medium, air. The ray is refracted at the surface of water, and bends away from the normal. When this ray reaches the eye of the viewer, it appears to come from a point A. Similarly, all points between A appear to come from corresponding points between B. Therefore, the pencil appears to be bent and shortened when viewed from the top. Similarly, a coin immersed in a glass of water appears to be raised, and a swimming pool filled with water appears shallower. Our atmosphere also refracts light. It is made of different layers. When light from any source passes through the layers of our atmosphere, it undergoes refraction many times. For example, stars appear to twinkle due to the refraction of light coming from them. Refraction of light causes mirages to be observed in a hot sandy desert. The retraction of sunlight causes advanced sunrise and delayed sunset. Laws of refraction. Refraction of light is governed by two basic laws. These are the incident ray, the normal at the point of incidence, and the refracted ray all lie on the same plane. For a given pair of media of different densities, the ratio of the sine of angle of incidence to the sine of angle of refraction is always a constant. That is, since n equals constant 3. This law was first stated by Dutch astronomer Willebroord Snellius, and is, therefore, known as Snell's law. The value of the constant is fixed for a set of two transparent media and depends upon their nature. It is called the refractive index of the second medium with respect to the first and is represented by the Greek letter U, mu. Refractive index is a ratio of two similar quantities and thus has no units. Refractive index of a medium with respect to vacuum is also defined as the ratio of the speed of light in vacuum to the speed of light in the given medium. Speed of light in the given medium. Rules of refraction. A ray of light traveling obliquely from a rarer medium to a denser medium, for example, from air to water, bends towards the normal at the surface of separation of the two media. In such cases, the angle of refraction is less than the angle of incidence too. A ray of light traveling obliquely from a denser medium to a rarer medium bends away from the normal at the surface of separation of the two media. In such cases, the angle of refraction is more than the angle of incidence 3. When a ray of light strikes the surface of separation of the two media at right angle, that is, the incident ray strikes the surface normally, it travels along the same straight line path, without any division for. If the path of light is reversed, it retraces its path. Refraction of light through a prism. A prism is a glass block that has a triangular cross-section formed by three rectangular faces. Here rectangular faces are the refracting surfaces and the angle made by any two adjacent surfaces is called the angle of the prism. XY is the incident ray. YZ is the refracted ray. ZR is the emergent ray. I is the angle of incidence. R1 is the angle of refraction at the first phase. R2 is the angle of incidence at the second phase. E is the angle of emergence. D is the angle of deviation. A is the angle of the prism. N and 1 is the normal at point Y and 2 and 3 is the normal at point Z. Dispersion of white light by a prism. The phenomenon of splitting of white light into its constituent colors is called dispersion. It was first studied by Sir Isaac Newton in 1666. He found that white light consists of 7 colors, and it splits into its 7 components when allowed to pass through a prism. The band of 7 component colors of white light can be obtained on a screen, in a fixed order. The order of 7 colors is violet, indigo, blue, green, yellow, orange and red, with I. This band of the 7 colors is called spectrum. Why does dispersion occur? Dispersion of light occurs because the refractive index of a medium with respect to another medium is different for different colors. Red color deviates, or bends, the least, whereas violet deviates the most. This is why red forms the top band of the spectrum and violet forms the bottom band. Two prisms are placed next to each other such that their adjacent faces are parallel to each other and a ray of white light is allowed to fall on the refracting surface of one of them. What will happen? The first prism on which the ray of light falls will disperse the light into its 7 colors. When this dispersed light enters the second prism, all the 7 components of light reunite and a ray of white light emerges out from the prism. Therefore, 2 prisms kept opposite to each other behave like a glass slab. Rainbow. The most fascinating example of dispersion in nature is the rainbow. It is visible in the sky after a spell of rain and is formed due to the dispersion of sunlight. Just after a rainfall, there are a large number of water droplets suspended in the atmosphere. These droplets act like tiny prisms. When sunlight passes through these spherical droplets, it undergoes dispersion. With a large number of water droplets contributing to this phenomenon, we get to see a huge continuous band of 7 colors displayed in the sky.